again with our metric conversions. In this example, we are going to look at a simple conversion changing 5.712 milligrams into kilograms. Now, to do metric conversions, the easiest thing to do is look at the prefixes. So here I have a prefix of M and a prefix of K. Now, if there are no prefixes, then we assume we are at the base unit. And a base unit always has a value of 10 to the 0, because this is the value that we are looking at. What is that exponent? So in the case of milli, we have 10 to the negative 3. Now if you don't remember that, you can always go back to your metric prefix sheet and look it up. For kilo, we have 10 to the 3rd. So now I'm going to look at, as I change from this number of 10 to the negative 3 to this number of 10 to the 3rd, am I getting larger or am I getting smaller? Well, 10 to the 3rd is 1,000, 10 to the negative 3 is 1,000th, so we are definitely getting larger. And our rule to remember is if we are getting larger, we are going to move to the left, the difference between the exponents. So here's my exponent of negative 3, my exponent of positive 3, and we are going to find that difference. So if I start at negative 3 and I count my way up to positive 3, I get negative 3, negative 2, negative 1, 0. Don't forget to go through 0. 1, 2, 3. So that's a difference of 1, 2, 3, 4, 5, 6 places. Now, which way am I moving it? Remember, I'm getting larger. I'm going to take this original decimal place and I'm going to move it left 6 places. So if I look at my number, 5.712, I'm going to take it and move it 1, 2, 3, 4, 5, 6 places to the left. Now I'm going to fill in all those bumps. So 5.712 milligrams is going to be 0.00000512 kilograms. And that will be my final answer. This next example is going to use units that you may not be as familiar with. So again, don't be afraid to look them up until you get more familiar with them. But again, these units that I show you here are not ones that we will use that often, but it does show you how to do these conversions. So I started with 4.32 nanograms. So you can see we've got a prefix. We got to figure out what does nano mean. If we look it up, nano is 10 to the negative 9. First, let's change it to femtograms. So look up F, and F is 10 to the negative 15. So negative 9, negative 15, even though 15 is bigger than 9, because it's negative, we are getting smaller. So as we go here, we are getting smaller. If we are getting smaller, we are going to move to the right. So what's the difference between negative 9 and negative 15? Well, that difference is 6. So smaller right, we have a difference of 6. So I'm going to take 4.32 and I am going to move it to the right 6 places. So 1, 2, 3, 4, 5, 6. Again, filling in these humps with zeros so that my number becomes 4, 3, 2, 0, 0, 0, 0. Put in your commas. I get 4,320,000. Now we can do the same thing. We can either go from this, because we're already in femtograms, and go to gigagrams, or we can go back to the beginning. So our G here, capital G, is going to be 10 to the positive 9. So this time I am, if I start at nano and go to giga, I am getting larger. So I am going to move to the left, the difference between the numbers. This difference is 18. So I am going to be moving it quite a few places. So I'm going to start way over here to make sure that I have some room. And I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Sorry about that. So again, filling in all these zeros or all these humps with zeros, you can see we have made an extremely small number here, but that's the simplest way to show you how to do the metric conversion. Next, let's look at some density problems. Again, density is not a very hard concept. It's just a matter of working with what units we have. So remember, density equals mass over volume. Once you get that, the rest of it is just as easy as plugging into this equation to figure out what we need. So in this case, we have 8.14 grams. That's going to go into our mass. 3.1 centimeters cubed. Centimeters cubed is a unit of volume. So we are going to take 8.4 grams and we are going to divide it by 3.1 centimeters cubed. Put that in your calculator and you get 2.7 grams per centimeter cubed. This time, in this example, we are given the densities. So this, because it has both units involved, we know this is our density. So we want to know mass, and mass is my unit of grams, has a volume of 0.35 centimeters cubed, so this is my volume. So I set up my problem as 3.26 equals x, because I don't know my mass, over 0.35. Now we have to solve for x. So to solve for x, we multiply both sides by 0.35. This will cancel here. Multiply this side by 0.35. So our answer becomes 1.14 equals x. So my unit in this case, 1.14 grams, would equal my mass.